multiplying binomials. Essentially, that's using the distributor property twice. You're going to multiply every term in the first parentheses times every term in the second parentheses. Some people call it the FOIL method. It's an acronym. It's kind of weak sauce in my opinion. So let's just go through this. If we multiply x times x, we're going to get x squared. If we multiply x times subtract y, we get minus xy. If we multiply y times x, we get plus xy. If we multiply y times a minus y, you get minus y squared. These middle two terms are like terms because they have the same variables, x and y, same exponents of 1. A minus xy and a plus xy cancel. Therefore, this simplifies to x squared minus y squared. We were multiplying here two conjugates. It's the same thing in each parentheses. The only difference is one has a plus between the terms, one has a minus. When that happens, the two middle terms always will cancel, and you end up with the first term squared minus the last term squared. Happens every time. Number 2 here, this is multiplying the same thing by itself. So this question could have also been x minus y squared. So we got x times x, which is x squared. X times a minus y is a minus xy. Y times a subtract y times an x is another subtract xy. And a minus y times a minus y is a plus y squared. Two middle terms are like terms. They have the same sign, so they're going to get bigger and negative. And that's all she wrote for that problem. Solving first-degree equations. So to solve these, we're going to use properties of equality for real numbers. And those properties are pretty simple. First property, in no specific order, says that you can add or subtract a number to both sides of an equation anytime you want. And the way to write that is if x equals y, then we can add or subtract any number, such as a, to both sides of the equation, and it doesn't change its value. Other property that's extremely important is we can multiply or divide both sides of an equation by the same number, and the equation is still going to be true as long as the number you're multiplying is not 0. So if x equals y, then we can multiply or divide both sides by number a as long as a is not 0. You use these properties all the time. So let me just remind you of how you use them. Supposed to find the value of x. So we want to get all the terms with x's in them on the same side of the equation. This minus 3x and this plus x are on opposite sides. We're going to subtract x from both sides of the equation. On the right side of the equation, minus x and a plus x cancel. On the left, we're going to have a minus x minus a 3x is a minus 4x. Now I want to get the 15 and the 3 on the same side, so I'm going to subtract 15 from both sides of the equation. On the left side, plus 15 and minus 15 cancel, so we got negative 4x. On the right side, 3 and minus 15 is negative 12. If we then divide both sides by negative 4, we're going to get x is 3, which is choice D. We use the addition, subtraction, division properties for this problem. Number 2, if x plus 5 is 10, what's x? It's obviously going to be 5, because if we subtract 5 from both sides of the equation, we're going to get x equals 5. Number 3, we got 2x plus 5 divided by 3 equals 9. This fraction bar means division. If we want to get rid of division, we do the opposite. We're going to multiply both sides of the equation by 3. On the left, you're multiplying and dividing by the same number. They cancel. On the right, 9 times 3 is 27. Going to subtract 5 from both sides of the equation. That's going to get rid of this plus 5 on the left. So now we got 2x equals 22. Divide both sides by 2, and you get x is 11. Translating words into math or algebra. So, just one moment here. Ed is 3 years older than Paul. Let's say that Ed is the letter E. Is almost always means equals. 3 years older means 3 plus. 3 years older than Paul. Let's say Paul is a P. So that means that this is translated to E equals 3 plus P. Easy peasy. Paul is twice as old as Mary. Paul is twice as old as Mary. Ned has and is are the same thing essentially, different parts of speech. Different tense, I should say. Same parts of speech, different tense, I believe. I haven't had an English class in a long time. 2 more than Ed, so whatever Ed has, Ned has $2 more. Bill, B, has equals 3 times as much money as Ted. Whatever Ted has, he has it times 3. That's just some examples of translating words into algebra.